How's it going? Good morning. I will be posting videos and work this week because the governor of New York told me I have to, and that's all well and good. I mean, guys, this kind of distance learning thing or continuity of learning, whatever they're calling it, it does put us a little bit behind. So, I mean, that being said, as much as I don't want to be up at 6 o'clock in the morning making you guys math videos on spring break, we are, in a time where we could use every little bit that we can get. Okay, so today it's a pretty straightforward day. I just want to go over some of the things that have to do with functions. Okay, so first of all, let's just talk about real quick what a function is. Now, being that we did a whole unit on functions, we should all be very familiar with what a function is and how it all works. Okay, so what is a function? A function is a relation. It's a type of relation. So not all relations are functions, but all functions are relations. So a function is a type of relation that shows, something in common. It's some relation between two sets of numbers. We typically call those numbers x and y. Or, as we know, because we did a whole unit on functions, x and f of x. Okay, so we're going to use both of these notations because they are kind of interchangeable. We talked about what some of the differences were. But what I really want to focus on today is why is this different than what we have been doing with, quadratics over the last couple of weeks. Okay. The big difference is we've been talking about equations. Okay. So equations you can solve. You can say this is the answer, okay? And essentially you can solve them because they had one variable, okay? So what we were saying was this. We said x squared plus 2x plus 1 was equal to 0, right? There's only one variable here. We can say that there is an answer to this. So if you guys go back to systems of equations, which we did in 8th grade, we did in 9th grade, if we have one equation, we can solve for one variable. Okay, so here's my one equation, and my one variable, even though it occurs twice, is x. Okay, so we can solve this. We can say this is the answer. This is the answer. Whatever x is, that is the answer. In this case, we had 2. Okay, for functions, we can't solve them. They're not solvable in the fact that a function might look something like this. X squared plus 2x plus 1. Now let's talk about this for a second. The difference between this and this. Yes, the equal sign's in the front. It doesn't matter. What we're more focused on is the fact that there are two variables here, x and y. So we can't solve this because there's two variables. All we can turn this into is something like an if-then statement. Okay. If x equals some number, then y equals another number. So I'll give you guys an example. If x equals 3, okay, well, we can say if x equals 3, what does y equal? Well, y is equal to x squared plus 2x plus 1. So all we have to do is plug in a 3 for everywhere we see an x. So y is equal to 3 squared plus 2 times 3 plus 1. 3 squared is 9. 2 times 3 is 6. 1 is 1. 9 plus 6 plus 1 is going to be 16. So if x equals 6, then y equals 16. Okay? And we can put whatever numbers else. We plug in 0. So y is equal to 0 squared plus 2 times 0 plus 1. Well, 0 squared is 0, and 2 times 0 is 0, and all we have left is 1. So if you think about it, for this function in particular, we could just put in whatever number we want. We could just keep doing this all day, right? We could just keep graphing x's, and we'll keep getting out y's. We'll keep plugging in x's to get out y's. And that's what functions are really all about. We can't say that there's one answer to this. There's actually infinity answers to this. We can just keep plugging in different values for x and say this is for y. Now, there is definitely some overlap here, and there's definitely some ways to look at functions as a way of solving equations. Okay, So we'll talk about that as well, but I don't want to get too far ahead of ourselves, okay? So the most common way people describe functions, and this is like almost become like a trope because it's been said so many times, is that we're going to have inputs that go into some sort of machine, and there's going to be outputs, okay? And we can represent our outputs as either y or f of x, right? Again, these two things will be interchangeable. We'll talk about both of them in the future, okay? So we're going to put in inputs and get out outputs, right? Now, what happens inside your machine could be different things, okay? Right now, we're focused on quadratics. So the big thing we're focused on is they will always have an x squared, okay? But there are lots of different types of functions, and we talked about what they were in the past, okay? So we've talked about quite a few. Now, what we've got to look at now is what we've been talking about, quadratics in standard form, okay? Now, we've been talking about standard form, which is ax squared plus bx plus c, right? We had a, b, and c. They were our coefficients. They were our numbers in front of the x's. All we're doing now is saying this, or this, okay? There are other forms, and we're going to be getting to them, and that will be very much related to what we were doing last week, okay? So our main focus of this is eventually we want to get to vertex form, okay? So again, these are your two standard forms, okay? Again, nothing has changed here, just they're going to be equal to y or f of x, okay? Same thing. Okay, your lead coefficients, you guys should know. Your lead coefficients is a, so it makes it a little bit smaller. Okay, your lead coefficient was a. Now, one of the great things about having functions in general was we said that there was a relation between x's and y's, inputs and outputs. As a result of that, one of the things we can do is we can graph these things, okay? Because there's not one answer, there's many different answers, okay? So we can graph this relationship between x's and y's, okay? Now, when we graph functions that are quadratic, we're going to get a shape called a parabola. Okay, so I'll write that one down. We're going to get a shape called a parabola. Okay, and I will give you guys, I'll show you guys what a parabola looks like. Generally speaking, a parabola will look, I don't know, something like this. 4, 5, 6, 7, 8, 9. Okay, and I'm going to try and draw this, although this is not going to go well because my drawing pad is not real great. Okay, I will draw the best I can. Okay, a parabola will be this U shape that looks something like this. Okay, you know, let me get you guys a better one. Okay, a parabola might look like this. Okay, something like this, okay? And that's the shape we're going to get. That's the relationship. As we plug in x's, this is what we're going to get out for y. So we'll talk to that very much in depth over the next few days and everything like that. But what I want to talk about today really is some of the characteristics of this graph. So again, we plugged in 1, we got out a y value. Plugged in 2, we got out a y value, okay? So this shape is called a parabola, okay? And your lead coefficient, in this case, a. So we talked about it, we said y is equal to, oops, sorry. Y is equal to ax squared plus bx plus c. This number up in the front controls the shape of your graph, okay? If a is a positive number, and here it's positive 2, 2x squared. Notice our parabola opens up. It's this shape, okay? It comes down, 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 hits the bottom and starts going up, 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 up. If I make this a negative number, notice the shape of my parabola changed. it now opens down. So if this is a negative number, this is going to open down. Okay, so this would be our parabola open down. This is what we call a negative parabola. So positive parabola opens up, and a negative parabola is going to open down. All right, a couple more terms will be done. Open on time. Okay, so your critical values. Your critical values are things you want to know about, where'd it go? This graph right here. Okay, so I'm going to put it there. Y is equal to okay, so say I have this parabola. First of all, positive, right? Positive. We know because it's positive because it opens up. It goes, this is a positive parabola. Again, think about it as a smiley face, right? Again, A is 1. Particularly A is 1, okay? So our critical values are these points that are highlighted on the graph, okay? So we want to talk about those, okay? So the first one we want to know is the vertex. Now, keep doing that. The vertex is right here. Okay, in this case, it's a decimal. Okay, don't worry. Not a lot of the ones we're going to be working with are going to be decimals. Now, the big thing is that your vertex is where it changes directions. So this was going down, 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 and then it stops. For a split second, it stops. It is not going down. It's not going up. That is our vertex. That is a very important. That's what we call a critical value for us. Okay. All right. Your other critical values. Okay, are going to be right here. This is your y-intercept, okay? And these are your x-intercepts, okay? One other thing we want to take a look at is there is something called the axis of symmetry. So this is, okay? This axis of symmetry right here, this blue line, cuts it in half, okay? So an axis of symmetry cuts it in half and it goes through your vertex, okay? So again, your critical values are going to be your vertex, which has the axis of symmetry or line of symmetry that goes through it, okay, and these other points. Your y-intercept, where it crosses over the y-axis, and your x-intercepts, where it crosses over the x-axis, okay? These x-intercepts are probably the most critical value for us, okay? And we can call them by other names. We can call these the solutions, or we can call these the roots, okay? So listen, there's a sheet posted online, you should be able to answer these first 7 questions. I will post the answers tomorrow. It's no big deal. Please send questions. If you want to take a look at what we'll be doing tomorrow, this is what we'll be doing tomorrow, okay? So a quick video just going over some of the vocabulary terms, guys. I hope this helps. Bye.